So we'll try it. We're going to talk about the properties of number, which is actually section 8, I think. But we're going to also throw in the distributive property, which is actually the section that we want to do. So we're going to do sections 1.7 and 1.8, which is the properties of numbers, basically. And we'll focus in on the distributive property because that's what we really want today. So, you've seen the properties of numbers probably before. You're going to want to make sure you get these down. Your book lists like 8 of them. I'm going to bring it down to like 5. Okay? So, the first property of numbers is the commutative property. And in a word, commutative property has to do with the order. In that I can change the order. So it's like, and for abbreviation we'll use CON. So the commutative property is going to be like A plus B is the same thing as saying B plus A. And A and B could be anything that I want. So 4 plus 10, we know, is the same as saying 10 plus 4. Same thing. Same if I'm multiplying it. So this would be like for addition. There's one for multiplication. A times B is the same as doing B times A. I could change the order. So if I had 3 times 5, that's the same as saying 5 times 3. I don't want to belabor the point. And that's for multiplication. Commutative property has to do with the order. Alright, I can change the order. Now, here's a question. Could I change the order of subtraction? No. If I do 4 minus 6, that is not the same as 6 minus 4. Those give me 2 different answers. But I can fudge it. Just watch. You don't need to write this down. What's the sign in front of the 4?
Positive.
Positive. So if I change the order by taking the sign with it, I could do negative 6 plus 4, and now those are the same. So, this is going to be important for all your, take the sign with its number. Okay? Don't fixate on the sign staying in the same spot. Move it with the number and you'll be okay. But in general, no. We can't have a subtraction, then leave the subtraction there, and then switch around. So basically, I changed it to an addition problem, and that was fine. So that's the commutative property. Next is the associative property. And in a word, this has to do with grouping. I can change the order of the grouping, and we'll use ASC for an abbreviation for that. The associative property. What do I mean grouping? Well, let's say I have 3 things. Maybe I have A plus parentheses B plus C. That's going to be the same as if I move that grouping. See, the parentheses are a grouping symbol. If I move the grouping symbol, now I have associative property, the group, the friends. There's a different pair of friends. They sit at the same table. Now, the group of friends is the same, though. Doesn't change the answer. So like if I had 4 plus 5 plus 10. The answer to that, I hope you see, is going to be the same as if I added the 4 and 5 together first. So that's the associative property for addition. But I could do it for multiplication as well. Trey, you should be writing these. I could have A times B and C in parentheses. And I could change the grouping and have A and B together with the C alone on the outside with no friends. Okay, so notice the order of the letters did not change. It's where the parentheses changed. So with the associative property, we're looking for what's in the grouping. So if I had 4 times in parentheses 3 times 2, I'm going to get the same answer as if I did 4 times 3 first. Now you might be thinking, what do I need these commutative associative properties for? Well, associative we'll get to a little bit more when we're doing combining like terms, but the reality is it helps you to do mental math faster. So like, for example, now this is actually would go to the commutative property. So I'll go back to the commutative property. If I was doing 4 times 10 times 3. If I wanted to do this really fast, I would actually do the 4 into 3 first, get 12, and then 12 times 10 is 120. Then I can do it in my head really quick. You might have seen, well, it doesn't make a difference, 40 times 3, and you can still do that in your head. But the point is, change the order of your things and it will be easier. Okay, so that's associative, commutative. Let's go on. Next, identity. I don't have a good one-word thing for this, but I'm going to try it anyway. The word same. As in, I get the same thing as I start with. So our abbreviation of this will be this, IDT, identity. Of course, if you don't think that you have to memorize that. I mean, you could write out the whole word. That'd be fine. So what do I mean same? Well, if I have A, and I want to get the same thing as I start with, I add 0 to it, and I get A back. And for multiplication, if I start with A, and I multiply it by 1, I get A back. I just get what I start with at the end. So like 4 plus 0 is always going to give 4. And 4 times 1 is always going to give 4. So this is for addition, and this is for multiplication. That means 1 is called the identity number of multiplication, and 0 is the identity number for addition. But the basic idea is I get what I started out with. Okay? We're getting towards the end here. Of this, anyway. The 0 property. This one, for now, isn't very important, but it is going to be very, very, very important second half of the year. The 0 property, I don't have a single word for it, but it's times 0. Anything times 0 equals 0. You're like, well, Mr. Kane, every third grader knows that. It's the first multiplication table, the 0 table. Everything's 0. Yes, but we can use this in algebra. So here's the use in algebra. Well, look up here. Let's say I have something, any something A, and I multiply it by any other something B, and I say that equals 0. Well, what must we know? Well, either A equals 0 or B must equal 0. One of these must be the case if I say A times B equals 0. So we're going to actually be able to use this to solve some very complicated things. So 0 property becomes very, very important. So, but for now, anything times 0 is 0. Pretty simple. So don't mess that one up. Don't confuse it with plus 0, right? That would be identity property. All right, now, we will practice the properties of numbers more tomorrow. For now, I want to focus on the final property that I want you to really identify, which is the distributive property. And distributive property basically means I can multiply into parentheses. Now, I can't multiply into absolute value. I can't multiply through an exponent, because order of operations, remember, multiply comes after exponents. But basically, if I have any letter A, or any group A, I can multiply into this. And we'll want to show that with arrows, like this, show what we're doing. And that equals A times B plus B times C. Or, well, A times C, sorry, because it's an A. So I multiplied into the plus. It doesn't matter if that's a minus, it could be a minus 2. So for example, if I had a negative out here, and instead I had 4 plus x, like that, I can distribute that negative into here. Well, what do I mean that negative? Well, it's like a negative 1. Negative 1 times 4 equals negative 4. And negative 1 times x is negative x. Do another example. Maybe I have 10 plus 3x. And I have out here a negative 5. It doesn't matter which side it's on, I can still distribute. I can distribute this way. Now, why doesn't it matter? Maybe you're confused by that. Use the commutative property, put the negative 5 first, because I'm allowed to change the order, and I get the same thing. I just skip this step. I just do it that way, because it doesn't matter. So, writing it the long way, I get negative 5 times 10, plus, see, I'm keep this sign, whatever it is, plus negative 5 times 3x. Well, negative 5 times 10 is negative 50, and negative 5 times 3 is negative 15. Well, where'd this plus sign go? Plus and minus become simply a minus, right? So, boom, done, answer, done, answer. I can't combine those, because they're not like terms, and we'll talk about that here shortly. Let's see here. What else could we do? We could do a fraction. Let's do a fraction. Just because it's a fraction doesn't mean, you know, get your undies in a bunch.
Some people are.
Okay, so I can distribute a fraction. It's going to be times each of these, right? So let's write it out. I mean, 3 halves times 6x. This sign's a minus, so minus 3 halves times 10. And I put the 10 over 1 because it's a whole number. And now my rules of fractions apply. I can put the 6 over 1. Can I cross cancel? 2 and 6. The 2 becomes 1 and the 6 becomes a 3. And can I cross cancel here? Yes. 2 and 10. The 2 becomes a, and the 10 becomes a. Alright? Now I just top times top, bottom times bottom. So I get a 1 in the bottom here, so I don't need it. So 9x minus 3 times 5 is 15. Done. So just because it's a fraction, don't get too scared. You know how to do fractions. It can be a decimal. That's fine too. We'll do another example. Let's do another example. Let's do negative 3/5. So I distribute this. Boom. Boom. So I'll write it the long way. Negative 3/5 times 10x. I copy down this plus sign. Negative 3/5. Notice how I make use of my parentheses. Now I'd rather use them too much than not have them when I should have them. Okay, so I'll put that over 1. If it's not in a fraction, I want to put it over 1, so I make sure I'm not multiplying denominators with numerators. I can cross cancel 5. I can cross cancel 5. Now you're not always going to be able to cross cancel. I'm just making them up such that I can. So this first one will become what? Negative 6x. And the second one will become? Yep. And I don't need that plus because plus minus is simply going to be minus. I don't want to have a bunch of extra symbols if I don't need them. And if this were a minus, minus minus would become a plus. Let's do one that's like that. One more example, and then I think we've actually done what we... Oh no, there's one more thing, sorry. Fake out. Let's do negative 2 times 5x minus 8y. So I can distribute that. I can can write my arrows below if I want, if I don't have room. So what do I get in the front?
Negative 10x.
And the next one?
Negative 16x. Log.
So what's negative 2
Oh,
Positive.
okay. Log
plus? There we go. There we go. All right, and we're happy because this isn't. I hope this isn't too bad for you. Here we have a Charlie Brown with 2 hairs. Oh, did you get that? I knew someone was going to say it. I was like, that was a little bit fast. Even for Mr. Kane, that was kind of fast, right?
We're going. Okay.
No, it's grumpy face. Okay,
You're a grumpy-
going
You're
on.
a grumpy.
Okay. Combining like terms. Then we can call this done. This isn't that bad. Like terms. Terms are like. Well, first of all, what's a term? Let's define a term. A term is a group, or groups rather, separated by addition or subtraction, or perhaps even both, if you have a lot of signs. Like terms have the same variables. Remember, variables are letters we don't know what they mean, or what they are rather, what they equal. They have the same variables raised to the same exponent. So, let's think about 3x. What does that mean? Well, that means 3 times x, which means x plus x plus x. 3 of them that I've added. And if I had negative 3x, that would mean negative x minus x minus x. So what if I had 2x plus 3x? Well, that's going to mean, the 2x is going to mean x plus x, not a plus. The 3x means x plus x plus x, which means 5x. And hopefully you saw a faster way. 2 plus 3 is 5, and then add an x to the end. Way faster. But I want you to see why it works, because when we get to doing exponents with them, then it can be confusing. So why does this work though? I want to show you why this works. Let me have you finish writing that. I'll show you why it works, and then you don't need to really do it that way ever. But here's why. So let's say I have 5x plus 10x. I'm not going to write out that. We say these are like terms. See, x and x. So these are like. I can add them 15. But here's why it works. Notice that the x is common to both of these. So I could write it like this due to the distributive property in reverse. See, I could distribute that x and get this back. So I pulled out the x. That's actually called, and we'll do it a lot later in the year, that's called factoring. I factored out the x. And now I can do order of operations. Do the parentheses, 15. Boom. Let's practice that one more time. Let's say I had negative 7xy plus 12xy. Notice what's common, xy and xy. So I can pull those out. So I just pull out the xy like that. Now I can do negative 7 plus 12, which is 5. So 5xy, and I'm done. So that's using the distributive property in reverse. So let's do one really complicated one with lots of like terms. And then if you can do that one, we're done and you understand and life is good. We'll even grow a third hair.
Oh man,
And only be half grumpy.
well, he evolved.
I thought that was the one you did.
Maybe it is.
Maybe it's the favorite eyebrows.
I don't know.
So here's my big kahuna.
My favorite fish.
So I distribute first, right? You see distributing happening here?
Yeah.
So what will I get on the first one? Careful.
10
Plus.
15x.
And what do I distribute here? You might be tempted to say 7, but it's actually a negative 7. Take the sign. Take the sign with it. So I distribute a negative 7.
Negative 14x. And negative 21.
And notice what's like. I'll use colors. The 10n and the negative 21n. See, I take that sign with it. And 15x and 14x. So now I just combine them. Well, what is 10 minus 21? Negative 11. And what is 15 minus 14?
1. So just x.
So plus x. I want that plus sign there because I don't want to switch to multiplication, and I'm done. Did you understand that? Raise your hand if you understood that. Good. Okay. Raise your hand if I don't get that. I'm lost. Anyone? No takers? Okay. Then we are happy and we are done with notes.
You forgot the hair. Yeah.